to derive or how to create a transfer function. So normally the transfer function is given by this trans g gs equals to first order, second order, and so forth. For first order system, it is given as g1 equals to 1 upon 2s plus 1. So how to write this in Matlab? So we can invoke this, or we can create this transfer function by first naming the transfer function as g1 and then using a built-in function tf, and in the bracket is basically a combination of numerator, so numerator is 1 and denominator is 2s, so start with 2 and then space and 1. So if you evaluate this, you can see that the transfer function is as what we have defined previously. So when we have this transfer function and then we want to have a look on the response of this transfer function, we do not have to use partial fraction and then take inversion of the transfer function and then plot using the response equation, so-called x or y and so forth. We just use this either unit step input or this impulse input. We can have a look on both. For example, if we want to see in terms of impulse, you just type impulse and then it will give us this response here, right? And then if we would like to see in terms of plot, proper plot, we can type step and then plot and then g1 and it will plot on this response for us with the typical graph of amplitude versus time in second, right? And then for second order system, we can do, or we can create the transfer function similar to what we have created in the previous order. So the second order transfer function normally is described by this g2 equals to natural frequency square and then s square plus 2 zeta omega n plus omega n square. And in Matlab we can first define what is the value of zeta and then define the value of natural frequency omega naught, and then from there we can define the component of the transfer function, which is a combination of numerator and denominator. And once we have done that, we can just evaluate this and it will give us this the continuous transfer function as we expected. And then if we would like to know the response of this system using unit step input, we can type step plot, and once we evaluate we can see that the response is according to case of zeta less than 1. It is what we expected because we have said that zeta is equals to 0.25. So that's why the plot is according to this oscillation, and this oscillation is gradually diminished as time increases to infinity.